So let's recap the photoelectric phenomenon, today's lab. So I discovered 4 new metals and I put them each into a little capsule, and they're labeled here in capsules 1, 2, 3, and 4, and they're in different orders for all different groups. And these are the names of the metals: lithium, banana beryllium, calcium, and palladium. And I forgot which ones I put in which capsule. So your job was to find out which one of those metals are in each of these capsules. So we're going to use the different wavelengths of light and give you flashlights that produce red light, green light, blue light, white light, and ultraviolet light. And I gave you the wavelengths, or approximate wavelengths, of those lights. Although you didn't need to use that information, you could have used it if you needed to. I gave you the formula here for the speed of light and its relation to the wavelength and frequency. So one way to keep track of this is to determine which wavelengths or colors have enough energy to eject electrons from the metals in each of these capsules. So I'm going to start here with the red light. It has the lowest frequency or the highest wavelength, or you can also say the lowest energy of all 5 of these lights. But first I'm going to turn on my gadget here to detect the ejection of electrons. So I'm going to need to set this up actually, because this is not set up. I'm going to take out capsule number 1, and I'm going to connect the red lead to the longer leg of this capsule. And I'm going to connect the black lead to the shorter leg of the capsule. And make sure these leads are not touching each other. And they're not. Alright, so I'm going to shine, my first light is red light. And notice I get a reading on my gadget, the electron detector, let's call it. And so that's all I need to know. I don't need to know the value of it, because I don't need to know the number of electrons that are being ejected. I just need to know that red light has enough energy to eject electrons off the metal in capsule number 1, for my group at least, or the station I'm in. So I'm going to record that here. Red light had enough energy, or the wavelength was short enough, or the frequency was high enough, if you want to say. So the frequency of the red light is greater than the threshold frequency of one of these metals. And so we would assume that since red light is the lowest energy light, that all these other ones will also detect electrons. Now I'm right underneath the classroom light, so I need to maybe cover that up, because this reading should be 0 on the electron detector. Alright, I had to dim the lights in the classroom or the lab. Okay, so now where are we? So we would expect every other light to also have a reading, and the green light does, the blue light does, the white light does, and finally the UV light does. And again, it doesn't matter that the reading is low or high, it just matters that that there is a reading. Alright, so there was electrons were ejected and detected by the gadget electron ejection detector by all 4 lights. Alright, so let's unclip this and hook it up to capsule 2. Alright, since I only have one hand, I put capsule number 1 back, and I connected capsule 2 the same way I did earlier. And I'm going to shine some red light, and so there's no detection of electrons being ejected by this gadget. So I'll move over to the green light. Nothing. Nothing. Not even the white light. Finally, the UV light is ejecting electrons. And that's the only one that has enough energy to eject electrons out of whatever metal is in capsule number 2. So again, I returned capsule number 2, and I connected capsule number 3 the same way. No reading from the red light. All right, I'm getting a reading from the green light, so we can expect readings from all the other shorter wavelength lights, because shorter wavelength is related to higher energy and higher frequency. So for capsule 3, whatever metal's in there, the energy of the red light wasn't able to eject electrons, but all the colors with wavelengths of green or shorter were able to eject electrons. And then finally here, I'm hooked up the capsule number 4. So I'm going to see if we get a reading, any ejections of electrons with the red light, and we don't. Nothing with the green light. And we are getting a reading from the blue light, so we can expect readings from the other 2, which are higher frequency, and we are. So capsule number 4. So capsule number 4, whatever metal was in there, we were able to get electrons off using the energy of the blue light, white light, and the UV light. So knowing that, we can say whatever metal has the lowest threshold frequency, which would be the banana beryllium, it must be the metal in capsule number 1, because all the wavelengths of all the colors had enough energy to eject electrons. And so the next lowest threshold frequency is caliceum. And so we can say caliceum must have been in capsule number 3. And palladium, with the highest threshold frequency, should correlate with the metal in the capsule that was only ejected by the frequency of the UV light. And that was in capsule number 2. And if you want to extend this activity, we could even calculate the kinetic energy.